This is day 7 of Advent of Code 2024 done in Go, and this challenge is called Bridge Repair. The historians take you to a familiar roped bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it will take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from the calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations, the puzzle input. So for example, we've got 190 and then numbers 10, 19, and so on. So each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Operators are always evaluated left to right, not according to precedence rules. Furthermore, numbers in the equation cannot be rearranged. Glancing into the jungle, you can see elephants holding two different types of operators, add and multiply. Only 3 of the above equations can be made true by inserting operators. 10 and 9 has only one position that accepts an operator. Between 10 and 19, choosing plus would give 29, but choosing asterisk would give the test value 10 times 19, 190. 3, 2, 6, 7 has these 3 numbers, so 2 positions for operators. Of the 4 possible configurations of the operators, 2 cause the right side to match the test value. 81 plus 40 times 27. Then 80 times 40 plus 27 both equal 326 when evaluated left to right. Then with 292 there is 11, 6, 16, 20 and can be solved in exactly one way. 11 plus 6 times 16 plus 20. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the 3 equations listed above is 3749. Determine which equations could possibly be true. What is their total calibration result? Okay, so let's get started. Okay, so the way that this would work, I think is pretty straightforward. So from the input, we grab the numbers. So we've got this number, which is the desired outcome. We then have all these numbers. What we then need to do is start with this number, and then we first test with plus, then do plus, 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 plus. If this equals it, cool, then we return true and this is added. If not, we then try asterisk. If that doesn't work, we go back to here, we change this to asterisk, then do plus asterisk. So essentially we're just recursively going through each of these numbers and then trying both plus and multiply, recursively doing that for every possible combination. And then once we've found the number, we then go, yep, that is, this is a valid, what would you call it? This can equal to this, essentially. So let's go to here and comment that line. So we have our lines and we can start off just iterating over it. So for line and range lines, we then need to do, first need to split it on the colon. So that would be strings dot split line on colon. And so we've got the parts. So target will equal to, so this will be, it would also return an error. I'm finally remembering that. So strings dot, it's string convert dot toy, and we pass in parts 0. So parts 0 is going to contain this one, and then the parts index 1 is going to contain the rest of this. So what we then need to do is numbers equal to, okay, so currently it's all strings. So what we should actually do is grab the number strings as a list. So we'll do number strings equal to strings dot fields, and that would be parts 1. We then do numbers, which will be a int array, but we need to do make with that. So this will be int, and it'll be a length of number strings. And we need to do for num string. This should be like that. Actually, no, we need the index for that because we've already made the list in range number strings. This will be numbers I is equal to string conv dot toy and num string. So we've got that. Okay, so we're still on the first line, which is fine. Everything's going to be contained into there. And is there something wrong with this? Oh yes, I forgot this part. Did it for that one, but not this. So we've got target, got that. But now what we need to do, let's create it here. We need to create the function that's actually going to do the comparison, and it will run check We'll go over both the, what would you call it? So it's going to iterate over all the numbers, try plus, try times, like that. And we will do evaluate equal to func, and we'll put in target, which is an int. We then do numbers, which is int array. We will do index, which is an int, and we will do current result, which is also an int. So we've got that. And what needs to happen next? We can do, so first I need to check if index is greater equal to length of numbers, we can return current result is equal to target. I need to set over here that it's returning a bool, so that. If this is not the case and we're in the current index, we can do current num is equal to numbers index, and what we can do is if evaluate target numbers index index plus 1, then current result plus current number, return true. So there's something wrong here. Undefined evaluate. Okay, so we need to actually define it first. So var evaluate, which is of this type. I think that's how it works. And then we remove that colon from there. So we're defining that this evaluate function or variable exists. And because we've already defined that it exists, when we're actually defining the definition of the value, we can then reuse it within here. So if this is true, return true. And if it's not, it would go down to here. We then do return evaluate this, and this will be times. Although I do want to change this, so let's do new result is equal to this if new result is greater than target, return false. Then we do that. Then we also do the same thing down here, new result, put that here, and then in this one we can do new result is equal to current result times current. If new result is greater than target, we then put that here. Actually, we will change that to less than, and we will put this inside of here. So I was just thinking, I mean, there's a possibility where the current number is 1, and if we did plus 1, it would go over the target, but if we did times 1, it would equal the target still. So that's why we do this. So if new result is, this we can do less than equal to target for that. We do this. If new result is less than equal to target, we would do this. So if new result is greater than target, and if new result is greater than target, return false. So we've now got our function evaluate. We do this. We then do if evaluate. So this would be target numbers index 0, current result 0. So if that, we then do output plus equals target. So I think that's all we need to do. So let's go back to here. We will grab this, put that into here, and we will run it to see if it works. 3749, and that's correct. So we will switch back to our actual input. We will run it, and hopefully it also works. We got this long old number, so we'll enter that in, and it was the right answer. Now, onto part 2. The engineers seemed concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then, you spot your mistake. Some well-hidden elephants are holding a third type of operator, the concatenation operator. 2 pipes, combines the digits from its left and right inputs into a single number. For example, 12 concatenate 345 would become 12345. All operators are still evaluated left to right. Now, apart from the 3 equations that could be made true using only addition and multiplication, the above example has 3 more equations that can be made true by inserting operators. So this number can be made true through a single concatenation. This one can be made true by 6 times 8, concatenating 6, then multiplying 15. And then this one can be made true by 17 concatenate 8 plus 14. Adding up all 6 test values, the 3 that could be made before using only plus and times, plus the new 3 that can now be made by also using pipe, produces the new total calibration result of 11387. So using your new knowledge of elephant hiding spots, determine which equations could possibly be true. And what is their total calibration result? Okay, so let's get started. Okay, so first thing, we can copy all of this code. It's essentially the exact same code, but with an additional condition. So we've got this. What we need to do, we'll combine the number onto it, combine the current number onto the result, then we just go through. So keep this code as well. So how would we do that? So new result. So we have the numbers, we turn them to both of them to a string, we combine them together, then we convert it back to a number. So we'll concatenated underscore equals, so there'll be string conf dot toy. Well, the question is, what goes into here? Actually, that's kind of straightforward. So we can, using like a string format, we just kind of insert the digits into the string. So that'll be format. Is that the one we're wanting? State, format state. I don't think that's what we want. Let's see what else is here. Sprint F. What do you do? Sprint formats according to a format specified and returns the resulting string. That sounds like what we want. So we've got our string. Then we'd have digit. Then we would have current result. Then we would do current number. So we do that, and then it's just this with concatenators less than equal to target. So let's switch to the test and make sure that's working. And it doesn't seem to be. Maybe I should test this here. Format dot print. So we'll print out current result, current number, and concatenated, and see what that is doing. So that does seem to be working. Actually, let's just do one single string. So we'll do target, current result, current number, concatenated. Let's see if there's any point where it's actually got it all. Oh, I forgot to change this here. So this needs to be if evaluate, return true. That's probably why it wasn't working. That's still returning the same number. Well, that's running. Okay, that seems to be working. Which one was it where? Let's try this. Find 156. So that would be at the very top. Yeah, so isn't that correct? Maybe let's do, I don't know, just correct equals evaluate. Then we can print below here, correct, then we return correct. Just so we can see if it's actually working. So I don't know if it is. So that's all false. Where's that? Was it 156? Okay, so that isn't working. How about we try target equals concatenated. Okay, so that is return true there. I'm going to put this at the top here. So the current result, get rid of this, and we will put this in. It's going to be something very simple causing this to not work, but I need to find that first. So why aren't you... Okay, I must be returning the wrong... adding in the wrong number or something. So that is 90. New result should be concatenated. There we go, found the problem. Remove all that. Now let's run it. Unidentified lines, what did I do wrong there? Oh, whoops, didn't mean to remove that. Just trying to get rid of all the format. Prints. Yeah, there we go. That looks like the right number, which it is. So we'll now put in our actual input and we will give it a run. And we have a new number, which we will put in as the answer, and hopefully it will be correct, which it was. So that is day 7 of Advent of Code 2024 completed in Go. If you like this video, make sure to like and subscribe.